We're just about ready to create a surface from our curve. I just want to point out a few of the things I've done here. Most importantly, I've stacked some points. Let's get in real close up here near the brim of that glass. And you'll see I've got a sharp corner here. And that's to produce that little lip there. And the way that I did that is by stacking control points. With the move tool, I can just grab one and move it out so you can see we've got multiple control points there. And the way to do that is to simply snap to vertex. Up here on your status line, you've got snap to vertex, snap to points. You can also hold down the V key. Hold down V, and then you can just move a point exactly right on top of another point. And that's how that works. The other thing I want to point out is down here, near the bottom of the glass, we want that to be flat. We don't want that to come to a point. I just want to make sure that that curve actually flattens out at the bottom. If we had something like this where it was pointing down, we would actually have this weird angle at the very bottom. Or if it was pointing up, we would actually have a little projection up there. So we want that just to be perfectly flat there. All right, so we're ready to make the revolve. I'm going to exit out of component mode. Right-click on the curve and choose object mode. And let's save. And to save, I want to save a new version. Instead of choosing File Save, which would overwrite my old version, I'm going to choose File Increment and Save. And because I properly set up my first scene file with the file name of revolve.0001.ma, the next file will be called revolve.0002.ma. So that just happens automatically. From now on, when I choose increment and save, it'll increment that file name. Cool, now we're ready to create our surface. Let's go back out to our 4 viewport layout, tap the space bar. There's the curve. Note that it's perfectly flat. It's two-dimensional because I built it in the front viewport. If we look at it in the top view, we can select it here. It's perfectly flat. Likewise in the side view, it's just a line. All right, so with that selected, we want to generate a surface. We want to be in the Surfaces menu set and go to Surfaces, Revolve Options. And within here, the main thing we want to do is change the output geometry to polygons. The reason that we want to do that is it's going to be easier for us to control the level of detail. We can create a NURBS surface, but eventually that NURBS surface is going to have to be converted into polygons in order to be displayed on the screen or rendered or output to, for example, a game engine. So since it's going to have to be converted to polygons eventually anyway, it's going to be more efficient and we're going to have better control if we choose polygons right now. Once we've done that, we get some additional options down here, and we can change all of this stuff later. But I do know at the very least that I want to choose quads. That means I won't see triangles, I'll see quadrilateral polygons. And here under tessellation method, I want to choose general. And what that's going to do is give me a bunch more controls for how the NURBS surface is sliced and diced up into polygons. That's known as tessellation. Tessellation is just a fancy word for tiling. How are we going to chop the object up into flat surfaces or flat polygons? Okay, so all I've done here is I've chosen polygons with quad output and tessellation method of general. Now when I click revolve here, it's going to create the object and it's going to close this dialog. But we will see something a little bit strange here. It doesn't look like a wine glass. It looks like some weird flat triangle. That's just simply because our tessellation options need to be adjusted for the particular object we're working with. With that object selected, let's go into the attribute editor, Control A, and go to the NURBS tessellate node. Click on that tab. And we want to open up Advanced Tessellation Options. And keep opening up General Tessellation Options inside that. These are the same options we saw in the Create dialog there, the Options dialog for the Revolve. So let's look at this. We've got tessellation in U and V. U is one of the dimensions and V is the other dimension. But they're not the X and Y dimensions like with a cube, for example. In this case, U is going to be the length of the curve. So the u dimension, we could imagine that, let's maximize this, tap the space bar. We can imagine that u starts here at the beginning of the curve. So that's a u value of 0. And it goes up and around, and somewhere around here it has a u value of about 0.5. And it goes around, and by the time it comes to the end, it's got a u value of 1. So that's how many divisions we're going to have in u here. And if I increase this, you will see what happens is we're getting more divisions along that axis. And then we've got the v-type, which is the number of divisions around the revolution or around the axis of revolution. I can increase the v number and we'll get more divisions that way. Okay, so that's how we can control the level of detail on a really basic level. But this default u-type and v-type is not really optimal in this case. It's basically dividing the polygons up into more or less regular size based upon the overall size of the object. That's what this per surface number of isoparms in 3D means. Okay, that's really a mouthful. That takes some explaining. An isoparm is a line on a surface where that surface has minimal curvature, where it's basically flat. And this is just saying we want to have 20 of those flat isoparms on the entire surface as measured in 3 dimensions. But that doesn't give us enough detail here. What we want is to create more detail. We want that to be based upon the distance between control vertices, so that where the control vertices are far apart, we will have fewer divisions or fewer isoparms. And where the control vertices are closer together, we will have more detail. That makes sense. We need more detail up here around the rim of the glass, and we need less detail here in the body. We can choose a different U and V type here. But I want to caution you and warn you, this is how you can crash your computer. If you crank up the U and V number and then change the U and V type, you can really easily blow up your computer. I mean, overload it until it will actually crash. Not just Maya crash, but your whole computer will crash. And you'll have to hit the hard reset button and, pray that it comes back up again. Okay, so very important. Before you change the type here, you need to dial these numbers way down to a low value of like 2 or something like that. And then the U type will change to per span number of isoparms. And you'll see even with a value of 2 or 3, we get a lot of divisions there. Same thing here, V type changed to per span number of isoparms. And a span is the distance on the curve between 2 control vertices. So what we're saying here is between 2 control vertices, we want to create 3 isoparms, both in U and V. And the isoparms then translate into polygon edges. So if we have a really high value to this, we're going to have insanely high level of detail. So a value of 3 or maybe 4 at the most is going to be fine. And we will see, once again, if we get in really close here, that we've got a lot of detail here around the rim where we need it. And we have a lot less detail here on the body of the glass where we don't need it. All right, so let's try a value of 4 and 4. I think that's going to be plenty here. Maybe for V number, I'll make it a little bit more, like 5 or 6. This is a pretty highly detailed object now. It really wouldn't be suitable for a game engine, but it would look great in a rendering for a movie, for example. If we had this on a tabletop and we wanted an extreme close-up on it, it's got lots of detail on it and it looks really good. If we want to check the number of polygons here, we can do that. Go up into the display menu and go to heads up display and choose poly count. And then you will see a readout here. And now we can see the heads up display is displaying the polygon count. And this is for the entire scene. We're seeing all of the polygons for the whole scene. If I select an object, we will see the polygon count for the selected object. That third column is for selected components. So if I selected a few points on here, we would be able to read out how many points I had selected. So this object has 7,000 triangles on it, which would be very heavy for a game engine. Really, we would need to optimize this and reduce that polygon count if we wanted to put it into a real-time renderer. But for a renderer that's going to output to files, like a movie, then this would be just fine. Okay, cool. Now, one last thing I do want to share with you to wrap up the lesson is the idea of the construction history. I can select that object, the revolved surface, grab the Move tool, and bring that over to the side. There's still a connection between this curve and this surface. So watch this. If I select the curve and then move it, we get a weird result here. We're seeing the dependency in action. We're seeing the connection between the curve and the surface. I'm going to press Z to undo that. This is why the curve needs to be exactly at the center here, because it's going to revolve around the y-axis of the world, and the position of that curve is going to affect the model because there's a connection between those two. So if I move this over, we can see we're getting a hole there, or we're getting, weird results. So undo that a couple of times. Just want to make sure that curve is back at position values of 0. So this is actually good. The fact that we have this connection makes it so that we can adjust the shape of the curve and observe the results in 3D here. As I'm looking at this, even though I tried to trace the outline of my image plane, it looks like the stem of the glass is a little bit too thick. I'll go back to my 4 viewport layout, tap the space bar, go over to the front view, get in a little bit closer, right click and go to Control Vertex. And I can select some of these points, like maybe these 3 here, and then move them over a little bit. And as I do that, you can see that it's affecting the 3D object because we got a connection. And in Maya, that's called the construction history. Basically, almost anything that you do to a model is stored in this so-called construction history. And this object now, the revolve, is dependent upon the shape of the curve. And if I select the curve and change its shape, we will change the shape of the glass itself, or the revolve. Once we've finished, we probably want to delete the construction history, thereby making all of our changes permanent. This is an important concept in 3D, is we basically at the end of our workflow want to bake the model or make it permanent. Because there's a chance that if we open up this scene sometime in the future, the construction history may not be calculated in the same way, and we may get a different result. This especially happens if you have a lot of commands, like if you're doing polygon modeling and you issue 400 commands, and then you have a construction history that's 400 nodes deep. It's going to calculate very slowly, and there's a very high risk that it's going to become corrupted. When you open that scene, especially in a later version of the program, those nodes may be calculated differently, and you may get a scrambled mess. So before you sign off on a project, you're going to want to delete the construction history. So let's just do that real quick. I'm going to save this state first. This is a state that has history, and it's important that I save this so that if I need to, I can go back to it and change it. Let's say I show this to my art director and he says, well, that's fine, but you know what, you got the shape of the stem a little bit wrong. You need to change that. If I have a version of the file with history, it'll be very easy for me to make those changes. If I don't have a version with history, I might have to start over again, and that would be a real headache. So before you delete construction history, you want to save the file. Let's do that. So just File, Increment, and Save. And now you'll see I've got Revolve 0003.ma. Cool. Now there's actually a couple different ways I could delete the construction history here. If I delete the curve, that will also delete the history, because there will be nothing for the surface to be dependent upon. That's one way to do it. But let's say I want to keep that curve, just in case. So I can delete construction history by selecting the object. Before we delete the construction history, take a look down here in the inputs for the selected revolve surface, and you will see Revolve 1 is listed there. That means that there is a revolve node, and that revolve node is in turn dependent upon the shape of that curve. All right, so with the object selected, go into the menus and choose Edit, Delete by Type, History. Once I do that, now I don't see any nodes over here. This is now a raw polygon shape. It's not dependent on anything anymore. And if I select that curve and start making changes, even just moving it, I don't see any effect on the revolve. undo that with Control Z. Or if I go into Control Vertex mode with a right-click marking menu, I can make changes to that curve. And there's no longer a connection to the shape of the surface. And now the history has been deleted. Very good. So let's go back to object mode here. And what I would do to save out a final version is place my object at the origin. Just restore this back to a value of 0. It's floating a little bit above the floor here, so I'm going to bring it down just slightly so that it's actually touching the floor. And then I'm going to make that the new 0, so that that's now the new default position. And that's done through a command called freeze transforms. So with the object selected, I'll go up here and go up to modify freeze transformations. And if we look at the options for that, you will see we can freeze the translate, rotate, scale, and a bunch of other stuff. All I really care about is translate. Click freeze, and now all these values get set to 0. So this is the new default 0 position for the object. I'll also rename it. Go up here to the channel box, and at the very top in the transform node, click on that and rename it, and I'll call it wine glass. Remembering that you cannot have white spaces. Press enter. And then finally, I want to save this out to its own file that doesn't have a curve in it, that doesn't have an image plane or anything. And that file will then be an asset that I can bring into a different scene. And to do that, with it selected, I'll go to File, Export Selection. And I'm just going to save it out as a Maya ASCII file. I have a bunch of other options, but I'm just going to do Maya ASCII. And I'll call this one Wine Glass. And it's going to be version 3, because it's Revolve 003 here. And I'm not going to increment this, but I'm just going to put the number 3 on there. And I can put the extension, but I don't really have to. That way I know that this is version 3. I don't want to put the word final on there, because what you will find is there is no such thing as final. If you put the word final on there, it's guaranteed that the next day you're going to need to make changes, and then you'll have a new final. Then it'll be final 2 and final 3 and final. So there is no final. Just give it a number and make that number match the version that has history. And click export. Okay, once we've done that, we don't really need to save this version because this is the version that has no history. I can just go to File, Open, and choose Wineglass 003. I don't need to save. And this is my final version. It doesn't have a material on it, but that would be for another lesson. Essentially, we've gone through the whole modeling workflow for Maya in one lesson, and I hope you've learned a lot. And keep watching Digital Arts Guild on YouTube in order to see more videos. And of course, check out lynda.com if you really want to go deep, because we've got so much content on there that we couldn't possibly put on a free channel like Digital Arts Guild. So I want to just do another little sales pitch for lynda.com here just to remind you that it is there and that it is a very valuable resource for learning all computer applications. Thank you.